Okay, we've been looking at the second derivative, of course, and differentiation in general. The last thing we're going to look at is what we call the primitive function. And the reason it's called the primitive function is because we're going to go back the other way. Let me explain. Remember the first idea we did with calculus was, how do we find the equation of a tangent? When we only know 1 point, and we needed 2 points to find the slope of a line, and that's where the whole calculus came in. We could find the slope of the tangent with only knowing 1 point. Well, then we said, well, what if we want to go back the other way? What if we know the equation of the tangent, but it's the actual curve that we want to find? How do we do that? Okay. Well, if we think about it logically, we know that when we differentiate, we subtract 1 from the power. So logically, to go back, to find where it came from, we'd add 1 to the power. The other thing we did with a polynomial was we multiplied by the power. So if I'm going to go back the other way, I'm going to divide. But the thing is, I have to divide by the new power, not the old power. Okay? So I don't divide by the n, I divide by the n plus 1. And just to confirm that, if I now said to you, hey, differentiate x to the power of n plus 1 divided by n plus 1, what would you do? You'd get that power, you'd bring it to the front, the n plus 1 would cancel with the n plus 1 on the bottom of the fraction, and then you'd subtract 1 from the power, and you get x to the power of n. We call it the primitive function because primitive is like saying going back to the beginning. Okay, so that's where it gets its name from. You'll notice I've also put a plus, a constant there. Because one of the things you'll remember we worked out is that if the function is a constant value, whenever you differentiate a constant value, you get 0. So if I'm going back the other way, there may be a constant there. We don't know. Because when we differentiated the constant, it disappeared. So if I'm going back the other way, how do I know what the constant was? Was it 1? Was it 20? Was it 5,492? Who knows? We'd need more information. So we go, look, plus some constant number, and unless you give me more information, I can't work out what that constant number is. All right. So here we go. We know the derivative is 3x to the power of 4. What was the original curve? So add 1 to the power, divide by the new power, but plus a constant, because there might have been a constant there as well. So 3/5 x to the power of 5 plus its constant. Just like differentiation, where we could do it 1 term at a time, same when we go back the other way. We can do it 1 term at a time. So the 6x cubed, add 1 to the power, comes power of 4 divided by 4. The x squared becomes x cubed divided by 3. The x becomes x squared divided by 2. Now the number by itself, of course, becomes 2x. Because whilst we're seeing the number 2 there, what we've really got is 2x to the power of 0. So add 1 to the power becomes x to the power of 1 divided by 1. Or another way of thinking about that is we know that whenever we differentiated some constant times x, we just got that constant number. So if I go back the other way, it just becomes, in this case, 2x. And plus, of course, there might be some other constant number there. We've got some tidying up we can do there because, of course, 4 goes into 6. There we go. 3 on 2, x to the 4, 5/3 x cubed, half x squared, plus 2x, plus some constant that we just don't know what it is. All right, let's find the actual equation, which passes through 1, 1, and has a gradient function of 2x plus 3. A gradient function. That's just a fancy name for derivative. Because if you think about it, the derivative was the function that allowed us to go and find the gradient. So a gradient function just means derivative. All right, so the derivative is 2x plus 3. So if I want to find the primitive function, we go back the other way. I'll get, add 1 to the power, I'll get x squared, but divided by 2, cancels with the 2. So it's just 1x squared. 3 becomes 3x, plus, of course, some constant number. The effect of the constant on a graph. What does that do, changing that constant number? Yeah. So what we're saying is we've got this, well, in this case it's a parabola. But I just don't know how high the parabola goes or how low the parabola goes. At the x value, because all I'm doing is moving up and down, the slope will be the same no matter what. This is where the extra piece of information comes in handy. We know this particular one goes through the point 1,1. So we can now locate exactly where this parabola is going to be. If I substitute in the point 1,1, we can work out our constant, in this case, -3. So we're talking about the particular parabola, y equals x squared plus 3x minus 3. So whenever we go back to the primitive function, plus a constant, if they give us some extra information that links the y and the x together, then we can go and find what that constant is. Okay, 10J. Enjoy.